Hello students, very good morning. Welcome to Narayana live classes. Today for class 10 students, we are going to discuss assignment number 19 on differentiation. Let us start with the first question. Using first principle, find the derivative of fx is equal to x square. First of all, let us understand what is the first principle. The first principle to find out the derivative, if fx is a function, to find out the derivative of fx, the first principle is given as f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. Okay, limit h tends to 0 f of x plus h minus f of x by h is said to be derivative of function f. What do you call it as? This is what we call as instantaneous rate of change. Instantaneous change in the function f. Okay, instantaneous change in the function f, that is f dash of x. For finding f dash of x, this is what we have to use. Using this particular limit, if at all you are finding derivative, that comes under first principle. Using that, we are trying to solve the problems now. Solution fx is given. First, let me find out f of x plus h here. What is that? X plus h whole square. Now, what is f of x plus h minus f of x for us? That is nothing but x plus h whole square minus x square. Right? So, that is otherwise x plus h plus x into x plus h minus x. That is otherwise 2x plus h into h, because x and minus x cancels. That is the value of f of x plus h minus f of x. Now, therefore, f dash of x is equal to what to write? Limit h tends to 0 f of x plus h minus f of x by h. That is nothing but limit h tends to 0 2x plus h into h by h. This h and this h cancels. Now we can apply limit directly. H, if you write 0, that becomes 2x. Okay? If there is no undetermined form or undefined form, you can directly substitute h as 0. Direct substitution we will call it as. In limits we have studied it as direct substitution method. So 2x. What is 2x now? F dash of x. F dash of x is nothing but derivative of f. That is nothing but 2x for us. So out of that is the derivative of f of x is x square. Okay. Now let us see the next question. Using first principle, find the derivative of fx is equal to sin x. Here also let us find out f of x plus h, that is sin of x plus h. Similarly, let us find out f of x plus h minus f of x. What is that? Sin of x plus h minus sin x. Okay, now you want this is to be simplified in this way. You can use transformations, trigonometric transformations to convert this. Sin c minus sin d is given by 2 cos c plus d by 2 into sin c minus d by 2. That is the transformation formula we have. So that is nothing but 2 cos of x plus h by 2 into sin h by 2. Right? This is the value of f of x plus h minus f of x. Therefore, f dash of x is equal to, let us apply the formula, limit h tends to 0 f of x plus h minus f of x by h. That is equal to limit h tends to 0. This is 2 cos of x plus h by 2 into sin h by 2 by h. Fine. Now, as we have a limit, here we have two functions as a product. We can individually apply limit. That is otherwise, if you apply limit for this function, you get 2 cos x into limit h tends to 0. This is sin h by 2. We have by h. So what I am trying to do, I will write by 2 into 2 here. To make it as a standard limit, standard trigonometric limit. Because we have limit x tends to 0, sin x by x, the value is given as 1. Limit x tends to 0, sin x by x is given as 1. So I am converting it into that form. So this entire value becomes 1. 1 upon 2. So that is 2 cos x into 1 by 2. 2 cancels here. So the result becomes cos x. Therefore, f dash of x here is cos x. So derivative of sin x is cos x. Derivative of sin x with respect to x, I can say that is cos x. Okay, let us see the next question. Using first principle, find the derivative of fx is tan x. Similar way, we have to find out f of x plus h, that is tan of x plus h. Similarly, we have to find out f of x plus h minus f of x, that is tan of x plus h minus tan x. How to simplify that? We don't have any transformation directly on tan c minus tan d. No way, we don't have. So what to do? Let us convert it into sine and cos. So we can write it as sine of x plus h by cos of x plus h minus. So I better write it as into cos x minus sin x into cos of x plus h. I am writing them as sine by cos form, and at the same time I am finding their LCM also. So we have cos of x plus h into cos x. Further simplification, it is in the form of sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b is sin a minus b. Sin a minus b is nothing but sin x plus h minus x by cos of x plus h into cos x. Here x cancels. We are left with sin h by cos of x plus h into cos x. That is the value of f of x plus h minus f of x. Therefore, we want f dash of x, that is limit h tends to 0, f of x plus h minus f of x by h, that is limit h tends to 0 sin h by cos of x plus h into cos x into h. Okay, that is equal to. We can apply limit individually. So we can write it as limit h tends to 0, 1 by cos of x plus h into cos x into limit h tends to 0 sin h by h. Fine. So this is the standard trigonometric limit. Its value is 1. And if you write h as 0 here, cos x plus 0 is cos x into cos x. There is no h, simply you can write it as cos x. So cos x into cos x is cos square x. So the result we are going to have as f dash of x as, so 1 by cos square x into 1, because it is a standard trigonometric limit, its value is 1. So 1 by cos square x is nothing but secant square x for us. So the derivative of fx is tan x is f dash of x, that is equal to secant square x. So derivative of tan x is secant square x. Now let us see the last question. Using first principle, find the derivative of fx is e power x. First, as usual, let us find out f of x plus h, that is e power f of e power x plus h. Now we want f of x plus h minus f of x, that is e power x plus h minus e power x, right? So both of them have e power x common, so we can write it as e power x times of e power h minus 1. Therefore, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. This is the first principle, that is equal to limit h tends to 0, e power x times of e power h minus 1 by h. That is otherwise e power x into limit h tends to 0, e power h minus 1 by h. This is a standard algebraic limit. E power h minus 1 by h, limit h tends to 0 is always 1. So that is becoming e power x into 1. That is otherwise e power x. Therefore, f dash of x is given by e power x. Means the derivative of e power x is e power x itself. So that is the end of this assignment. Thank you. Have a great day.